we are going to talk more about quadratics. We've kind of touched on them a little bit when we were looking at our transformations. We saw some involving parabolas, but we are going to get into more detail about how to graph them and those types of things. The first thing I put on here is a little bit about polynomials, because quadratics are a type of polynomial, and we are going to be getting into a lot more detail with all the polynomials. So you're going to see this stuff again, but I figured it would probably be beneficial to see it more than once, so I throw it in now and then we'll throw it back in later when we need it. A polynomial, the actual definition, it looks kind of ugly. It's just saying n is the highest power of x, okay, but it's a non-negative. So your highest power of x has to be positive. And polynomials, all of your exponents are whole numbers. 0, 1, 2, 3, 4. We have nice numbers. The a's in front are representing coefficients. They're just numbers that are multiplied with your x's. So a polynomial could be 3x squared plus 2x plus 1. Okay, or it could be negative 7x to the 12th and 5x to the 4th and 3. We can have a lot of different things, but the key, all of your exponents are whole numbers. We're not going to have negative exponents in a polynomial. We don't see fractions or negative exponents, decimal exponents, any of those types of things. When we're talking about that, some terminology that goes along with it. The degree, like I already mentioned, is just your highest power. Okay, in this particular scenario, it was the n. The leading coefficient is the coefficient of the term with the highest power. Okay, so if n is my highest power, the a in front of that is my leading coefficient. It does not necessarily mean the first one in the problem. Okay, you have to look. If I mix the terms up, the leading coefficient is still the one with the highest power of x, not necessarily the first one that's listed in the polynomial. And a constant is just a term without a variable. That down. So for each of these polynomials, we want the degree, leading coefficient, and constant. So the first one, degree. What is the highest power of x? 1. Leading coefficient. This is the term with the highest power of x. What is its coefficient? And then my constant, what is the term without a variable? And since it was a -1, it would be a -1. All right. Second one, I told you that polynomials, the x's don't have any radicals. It's okay if the number in front of the x does. Your coefficients can still have fractions or radicals with them. What is my degree? What is my leading coefficient? 1. That's term highest power, just a 1 in front of it. What is our constant? There isn't one, so it's just a 0. All right, last one. What is my degree? 3. Here's the term with the highest power. What is the leading coefficient there? What is my constant? 5. Any questions on this? Just gonna get used to some terminology. If our polynomial is just 0, that's what's called the 0 polynomial, and that technically has no degree. Because isn't 0 the same as 0x, which is the same as 0x squared, or 0x cubed, and I could keep going all day. So you can't tell me the degree because you could put x with any power with that. Now, if I just give you any other constant, if I say 3, is 3 the same as 3x? No. It would have to be x to what power? 0, because anything to the 0 power becomes 1. So if it's just any other constant, that's a degree of 0. Degree is kind of like saying how many variables are there. Okay, if it's a constant, there are no variables, so our degree is 0. Quadratic function is a special type of polynomial. And what do I mean when I say quadratic? What are we seeing? We see that square, so it's a polynomial of degree 2. So with our quadratics, it's anything of the form f of x equals ax squared plus bx plus c. That is the standard form for it. So 2 is the highest exponent. When we graph it, what will the graph be? The graph of a quadratic is always a parabola. Parabolas can open either up or down. If we think about a parabola facing upward, then it has a maximum or a minimum point. This is a minimum. If it opens down, it has a maximum. What is another name for that point? That high or low point on the parabola is called the vertex. Bless you. What is the vertical line that goes through the vertex? The axis of symmetry is that vertical line going through it. So our techniques for graphing these are going to kind of vary depending on how the equation is written. Standard form is the one that I already gave you. F of x equals ax squared plus bx plus c. But sometimes we see them in vertex form, which is kind of what we saw like on our last chapter when we were doing transformations. These quadratics were always written in vertex form. F of x equals a times x minus h squared plus k. Transformations are what we've seen before. So hk is actually going to be the vertex because we know that subtracting h, we move it to the right, adding k, we move it up. So it shifts that vertex there. Kind of like when the circle formula, the x minus h squared plus y minus k squared, the hk was the vertex, same thing here. All right, so we are going to talk about our strategies for graphing these quadratics depending on how they're written. The very first one I gave you, okay, I'm kind of doing this one to make a point. If I asked you to graph f of x equals x squared plus 4x minus 4. We can't just look at that and know the transformations because it's not written in vertex form. This is just standard form. So if I didn't give you any other clues, we would go back to how we started everything. If we didn't know how to graph it, what did we do? Make a t-chart. So could we do that? Absolutely. All right, what do you want to plug in?
0.
So if I put in 0, 0 plus 0 minus 4 is negative 4. If I put in 1, 1 plus 4 minus 4 is 1. If I put in a 2, 4 minus 4 is 8. Okay, is this, do I have a clear parabola yet? No, what should I plug in? Okay, if I put in negative 1, so 1 minus 4 minus 4 is -7. Okay, is that enough? No, let's keep going. If I put in negative 2, I get 4 minus 8 minus 4, which is negative 8. I still don't have a clear parabola. If I put in negative 3, I get 9 minus 12 minus 4 is negative 7. Do I finally have it? Yeah. Why did I have to keep putting in those points? I need to find that vertex, that point where my graph bounces and starts going the other way. Now, you could certainly keep plugging in points, but at the very least, we need this much to get our vertex. And if you chose to go ahead and put in a couple more, you certainly could. If you put in negative 4, you get out negative 4. If you put in negative 5, you get out 1. And so now we definitely see that parabola shape. So this worked. Why is this not a great strategy? Takes forever. You know, we kind of got lucky. We found our vertex fairly soon, but we're just blindly picking numbers and hoping for the best. What if my vertex had been at like 7/8? Would I have probably guessed to plug in 7/8? No. So we got it, but this is not a good strategy moving forward. We don't want to take this much time on every single problem going through all those points. Can you tell me domain and range? What's our range? Okay, so we don't like that strategy. If it's written in vertex form, we can do transformations. We know our parent function, right? We've done that before. 0 squared is 0, 1, 1, 2, 4, 1, 1, negative 2, 4. You can do more if you want. If you're doing transformations, your parent function is dash. What would this negative 2 do? Flip over the x and right, a vertical stretch. Some of you are great doing it like that. Some of you need to write out these points like we talked about in class, and that is totally fine. So if you're a person that the stretching and shrinking is hard for you, then write out your points. This in front changes y and it does what it says. So it says take your y times negative 2. So we still have 0, 0. 1, negative 2. Negative 1, negative 2. 2, negative 8. So I notice, especially on stretching and shrinking, quite a few of you are writing out those ordered pairs, and that is perfect. That shows you exactly what to do. outside is y, does what it says. So I have negative 2 on the outside multiplied with it, so I just take all my y's times negative 2. Was that faster than our other strategy? Yeah, absolutely. And we know our vertex is correct. What's the domain? What is the range? Any questions so far? Right. Try one more. You guys sketch that graph for me. Everybody should be able to do that. Sketch domain and range. Function. What's my transformation this time? Down 1 and right 3. So take each point. Right and down. And then we get our graph. Domain. Range. Good. Can we handle it if I ask you to do transformations? That's kind of review. We were doing that on our test yesterday. If it's written the first way, in standard form, that ax plus by, ax squared plus bx plus c, we need to think about it differently. So there's different options. We could try to factor it like this, kind of a completing the square type thing. So we did it with circles. We could do it here and complete the square to graph it. We can also remember in Mrs. Keller's class, she taught you a formula to find the vertex. You guys remember seeing that ever? So there is a shortcut to this, and it has to do with the result if you were to go through and complete the square. It's kind of what happens. The x value of the vertex is the opposite of b over 2a. That gives you x. If you look in the book, it gives you a formula for the y, but I think it's much easier just plug it in to get y instead of remembering a second formula. Once you know what x is, you can plug it into the equation and get your word pair. So that's your formula. Axis of symmetry is this line. X equals the opposite of b over 2a. We weren't really drawing the axis of symmetry on the last few problems we did because that wasn't necessarily our strategy. But if you have the vertex and the axis of symmetry, you know the graph is the same on both sides. So then we need some more points. You can find the y-intercept. How do you find a y-intercept? That gives you another point, and then you reflect it over the axis of symmetry to get your final one. So let's try a couple of these, and that'll probably be about where we stop today after we get through that. Alright, so I want vertex, axis of symmetry, y-intercept, domain, and range, and then we'll graph it. So if it's written in this form, rather than just blindly picking points, let's find the vertex. To find the x, we do the opposite of b over 2a. Remember, it's ax squared plus bx plus c. So what is my b value? 2. So we have negative 2 over 2 times, what's my a? So negative 2 over 2 gives me negative 1. Vertex is an ordered pair. So to get my y, I plug that into my equation. So negative 1 squared. 2 times negative 1 minus 5. 1 minus 2 minus 5 is negative 6. So my vertex, you write it as an order pair. Negative 1, negative 6. And I can go ahead and plot that. I know that is the vertex of my parabola. We don't have to do the whole T-chart. The axis of symmetry. That's a line. So x equals the x value of the vertex, which is -1. So we're just talking a vertical line going through -1. You dash that, or you graph it as a dashed line. It's not technically part of the parabola itself, but we're going to use it to get our full graph. So what that means, that's a line of symmetry. So the parabola is the same on both sides of it. It's a mirror image. How do you find a y-intercept? We put in 0 for our x's. We get -5. So 0, -5 is a point on my graph. And once I have that, how do I get a third point? Can I reflect it from my line of symmetry? We know this is 1 away from the axis of symmetry, so you just go 1 away the other direction. So we're making a mirror image. Now, if you wanted more points, could you plug them in? Absolutely. My rule is 3 points, but if you wanted a better graph, we know where the vertex is now. Could you plug in a 1 if you wanted to? Sure, that would give you out -2, and you could do the mirror image. You know, you can get more points if you want. My rule is at least 3. So then we can draw our parabola. What is the domain? Every single time. Every parabola has the same domain. But my range, what's that going to be? -6 to infinity. And -6 gets a bracket because we do hit that point. All right. B. So my vertex formula is x equals the opposite of b over 2a. So opposite of b would give me 6 over 2 times 3. We get 1. 6 over 6. Find the y, we plug that in. So we get 4. So my vertex is the order pair 1, 4. Axis of symmetry, we've already done the work. How do we find it? Yep, it's just x equals the x value of the vertex, so x equals 1. Okay, it's just that vertical line going through the vertex. Right? Then the y-intercept, how do we find that? Put in 0 for all of the x's, and we get +7. So then I can reflect that across my axis to get a third point. We have our parabola. Domain. Range. 4, 2. Is this okay with everybody? We're going to do one final graph and then I'm done for today, okay? So, vertex. X equals opposite of b, -8, over 2 times -2. Get y, we plug that in. What's that give me? 5. So my vertex is a point 2, 5. All right. The axis of symmetry then is x equals 2. I will be kind of a stickler there. It is a line, so I expect the equation of it. X equals 2. Y-intercept. You put in 0 for all of your x's, we get -3. So what's going on with this parabola? It's negatives. So it's upside down because my square term was a negative. That flipped it. Reflect our y-intercept. It was 2 away from the axis of symmetry, so you go 2 the other direction. And we get our domain still positive infinity. The range this time is all right, so we have more to do. I'm going to go ahead and give you as far as you could get on your book problems, but I am not collecting these tomorrow. Okay, so I'll add some more to the list and we will turn it all in on Monday. So it's totally up to you. If you don't get it, you have some time to work in class. If you don't want to work on the rest and you plan to do it over the weekend, that's fine. But no, I'm going to add a few more tomorrow.